is already over x minus 1. What happens when you multiply it by x minus 1? Cancels, good. So then we would multiply by x plus 2. And then we add it to b, which is right now over x plus 2. When we multiply by x plus 2, that just cancels, turns to 1, and then we would do x minus 1. Okay, there we go. We've got this. Now we can solve. 3x is still going to be on the left. And we're going to have ax plus 2a added to bx minus b. So this is all still equal, haven't changed anything, but now we're going to use step number 5. We're going to use algebra and equate the coefficients that are the same. So in this we've got x's, and we've got our constants, which I'm just going to put a 1 there. So our x's, we've got 3x is going to be equal to ax plus bx. And then we don't have any constants on the left side, so we're going to put a 0 is equal to 2a. Oh, sorry, no, not a plus, it's a minus. Okay, we have 2 equations and 2 unknowns, a and b. Can we solve this?
Yeah.
Absolutely. 2 equations and 2 unknowns, you can do that. In the first one, we can factor out an x out of all of those. And so we'd still just be left with 3 equals a plus b. And in this one, 2a minus b is equal to 0, so we could say b is equal to 2 times a. We can take that, plug that back into the first equation, right here. So 3 is equal to a plus 2a. So we just took this equation right here, b equals 2a, and put it into right here for the b. So 3 equals to 3a. What is our a?
1.
And then what is our b?
2.
Great. Okay, so we solved that for these constants. Let's write that up at the top. We still have 3x over x minus 1 and x plus 2. And it's going to be equal to a over x plus 1, or x minus 1, sorry. What was our a? 1 over x minus 1 plus our b, which was 2 over x plus 2. And there we go with our answer. Good job, guys. We just did a partial fraction. How can you check your work here? What did you say?
I just I don't know.
Do you know how to add these fractions together? 1 over x plus 1 plus 2 over x plus 2? Good. Make the denominator the same by multiplying them by the opposite. So x plus 2 and then x minus 1. And you can check your work and make sure that it should go back to the same thing that we had before. All right, so let's go to the second one, situation B, where there's repeated linear factors. We've got x minus 3 over, and then parentheses, x plus 2 and x plus 1 squared. So first, yes, we jumped ahead. Is it a proper fraction?
Yes.
Yes, the degree of the numerator is less than the degree of the denominator. 2, is it factored?
Yes.
Yep, it's already factored. Are there repeating factors?
Yes.
Yes, so we are going to have to use number 3 on this. Let's go ahead. So what partial fractions am I going to have? A over x plus 2, good. And then add it to e over x plus 1, good. And then we're going to add it to another one. C over x plus 1 squared.
Wow. Okay. Why is that squared?
Okay.
That would have like 3x squared.
Right, you're going to think that, but it'll all work out. So for our linear factors, we're assigning the sum of partial fractions, and if they repeat, you have to keep on going and put these in here. So we had one that repeated twice, so we're going to have a over px plus q, and then another a2 over px plus q squared. So however many times it repeats, you work your way up to that.
So the C would just be like a B2.
Yeah, it would be like a B2, but we're just going to use C because it's going to be easier when we do our algebra.
So if it was cubed, you do like d over x plus 1 cubed?
Exactly, yeah. We'll keep on going as many times as it repeats.
So if you had something that was cubed, would you do b over x plus 1 and then c over x plus 1 squared, and then b over x plus 1 cubed?
Yes, exactly. Yeah. So we keep on going until you reach that power right here. However many times it repeated. That was our n. We only had it twice, so we do it only the twice. Okay? So now we want to get this all together and have just x minus 3 on the left-hand side. How are we going to do that? Multiply again. So what does a get multiplied by?
X plus 1 squared.
Okay, we actually only need to do the x plus 1 squared once, or x plus 1 squared. That'll get rid of the, that's the only thing that the x plus 2 is missing for its denominator. So a times x, well first what does x plus 1 squared go up to?
X squared plus 2x.
Plus 1. Okay, there it is on the side, so we'll put that x squared plus 2x plus 1 all times a. And then what does b need to be multiplied by? X plus 1 and
x2.
yes. Okay, and what does that become? X squared plus 3x plus 2. Good. And then what does the c need to be multiplied by? Yep, just x plus 2. Sorry.
Wait, why did you get x squared plus 3x plus 2?
Yeah, how'd you get
That is x plus 2 multiplied by x plus 1. Because we've got x squared plus 1 squared here on the bottom, but it already has one of them. So when you multiply this times x squared plus 1 of them is going to cancel out. But then over here you have to still do the x plus 2 squared because there's not one of those in the denominator there. Good question, thank you. Okay, so now let's write this all out in 1x minus 3 on the left-hand side. We've got ax squared plus 2ax plus a. And then what do we have? Bx squared plus 3bx plus 2b plus cx plus 2. Okay, good. 2c, you're right, thank you. Way to catch me. Plus 2c, good. So now over here, we've got some x squareds, and we've got some x's, and we've got some constants. So first with our x squareds, how many x squareds do we have on the left-hand side?
0.
0. No x squareds is going to be equal to our ax squared plus our bx squared. How many x's do we have on the left side? 1x is going to be equal to what on the right-hand side? 2ax plus 3bx plus cx. Good. So let's cross these ones off as we're doing them. Cx, 3bx. And now, what is our constants on the left side? Negative 3 is going to be equal to a plus 2b plus 2c. Good. So we have 3 equations and we have 3 unknowns, a, b, and c. Can we solve this?
Yes.
Good. Yes, we can. So let's take the first one. We can factor out an x squared off of every side, and then we're just left with 0 equals a plus b. So let's put, let's do b in terms of a. b is equal to what? Negative a. Good. So, and let's plug that into this third equation right here. So we've got a plus 2b plus 2c, but we know our b's are negative a. Oh, actually, you know what? Sorry, I'm going to switch that. We're going to solve in terms of a. What was a equal to? Negative b, same thing. Good, they're just negative out of each other. Okay, so a plus 2b plus 2c into this second equation. Now let's do the third. second equation, that one's gonna look easier. Okay, so we've got 1 is equal to 2a, but we know HA is negative b plus 3b plus c. So we've got negative 2b and 3b, what does that make it? 1 equals to b plus c. So that's a good equation we're going to use into this third one. We could factor this third one into a plus 2 times b plus c. Does everyone see that? Just factor it out at 2. And we know b plus c is equal to 1. So negative 3 is equal to a plus 2 times 1. So what is a equal to? Negative 5. Good. Now we have a. What is b? 5. Good. How did you get that? Into the first equation. A equals negative b. So whatever a was, b is just the opposite of the negative of it. And then what is c? Negative 4. Good job. Okay, so now over here on the side, what's going to be our partial fractions? We've got a over x plus 2. What was a? Negative 5 over x plus 2. And then b was 5 over x plus 1. And c is negative 4 over x plus 1 squared. And there we have our answer. How can we check our work? Yep. Add these back together and see if we get our original equation.
I don't like that area.
So on the bottom, when you put negative 3 equals a plus 2 times b plus c, I don't see where that came from.
I just factored out a 2 from b, 2b, and 2c. I factored out a 2, and that still remains b plus c.
Okay.
And then we had this equation, b plus c is going to equal to 1, so we can plug in a 1 right over there.
So you don't have to set answer equal to x minus 3 over x plus 2.
Yeah, we should. We should. Still, there still should be this big equal sign and this right here. I just kind of ran out of room.
Okay.
We'll have a little bit more room on the next one. Good on that one. So that was repeated linear factors. Now turn over your pages. Situation C are non-repeated quadratic factors. So step number 1 is proper fractions. Is this a proper fraction?
Yes.
Why?
3 is less than 3.
The degree of the numerator is less than the degree of the denominator. Now, number 2, factors. Is this a factor? No. Who's going to factor this for me?
It's like x plus 1.
2x plus 4, we'll leave that on the top. But the denominator can be factored to
X plus 1 times x squared plus x, I don't know.
pretty close.
X squared and then x minus 1.
No, close. You're thinking the right lines though.
It's x minus 1 in parentheses.
Okay, there we go. That's where we'll start. X minus 1 in parentheses, because we've got a cubic and there's a negative sign here. So we can factor that.
We do x
X
squared
minus 1 and then what? X squared, good.
plus x
Plus x plus 1. Good. So what kind of factors do we have in the denominator here? 1 linear and 1 quadratic. Good.
Did you factor the numerator?
You could. Is that going to help us cancel anything on the bottom? No, it's not. So we could actually just leave it as it is. If it does factor something out and you can cancel a common factor, then yes, go ahead and do it. Okay, so what are we going to have over here? First our a over what? Good. X minus 1. Good job. And then what are we going to have that is